Okay, question 7 is features the same price demand function and the same that we dealt with for I think exam 2. And it's the exact same question as the practice. We did it in class. We did it for the practice exam as well. And so we have a price demand function, and we want to find the revenue function. And so all we need to do that is multiply x times 2000 minus 60x. And it occurs to me that I had that here, and then I eliminated it, but that's x times, in parentheses, 2000 minus 60x. If you expand that out, that's negative 60x squared plus 2000x, or 2000x minus 60x squared. And we're supposed to calculate all of these revenues given these manufactured quantities. And so for 1,000 items, then our revenue is 1,940, and et cetera, et cetera. All the calculations are here. I don't really think that that's necessary, but I went ahead and put them here. They're not all that informative, except that they do show you could determine the values by either plugging into this version of the function, or the one after you multiply the x through. But anyway, those are all the values. We calculated these values several times in class. I think everybody is reasonably familiar with that. If you have any questions about it, by all means text me or call me, although tomorrow is probably not the best time to do that. I mentioned in the announcement that I'm going to be with my in-laws for a good bit of the day tomorrow, so I don't really want that interrupted. All right, and so now then we will move on to number 8, which is a little bit more work. With number 8, we use the revenue function from question 7, which, by the way, I don't think anybody got wrong on the second exam. So I expect nobody will get it wrong this time. It's the same type of question. And so we're asked to use that revenue function and this cost function to determine the profit function. Well, profit is just revenue minus cost. What are you taking in minus what are you spending? And the only thing to caution you about here is to distribute this negative across both of these terms. There were some people who missed that on that second exam. The revenue function is listed here, or it's shown right here, negative 60x squared plus 2000x. And you've asked me before, why do I put this term first and the book puts it second? My question would be, why does the book put it second? Because this is the more typical representation. Anyway, when we subtract that cost function, just don't forget to distribute the negative here. So that's minus 250x and minus 4,000. And then when you combine like terms, 2000x minus 250x is 1750x. And then we're supposed to determine the break-even points. Break-even points are where you're spending as much as you're taking in, and so you don't lose any money, but you don't make any money. Break-even means that your profit is 0. So we set the profit function equal to 0 and solve for x. And so on your test question, divide out the biggest number you possibly can from these three terms. In this case, it's -10. Include the negative, and don't make that part of your calculation for your solution, because it's not going to affect the value. So we factor out a -10, and I gave the hint on exam 2 that you would factor with a 2x here and a 3x here, and then all you had to do is come up with the values that would go here and here. And I was surprised at how many people couldn't come up with two numbers that would multiply together to give you 400. And then multiply together multiply together give you 400, and then the two multiplications added up would give you -175x. These multiplications, 2x times -80 and -5 times 3x. That is what I sort of hopefully laughingly referred to as the oi in the FOIL. It's the outside terms multiplied together added with the inside terms multiplied together. That will give you this term in the middle. So this is the factorization that will give us this function back. And so we take this first factor, 2x minus 5, set it equal to 0, and solve for x. That gives us 5/2, which as a decimal is 2.5. And then you set this factor, 3x minus 80, equal to 0, and solve for x. That gives us 80/3, or 26.67 as a decimal. And so we're asked also to find the intervals of profit and loss, and we're asked to determine what production level maximizes profit and how much is the profit. So this is a pretty this question is there's considerable work to do here for your points. Well, these are our break-even points, and so in between those are the places where we'll make profit. And so that's this interval right here, from 2.5 to 26.67. And I've used curved brackets because we don't make a profit at either of these points. We break even, making 0 profit. And then we lose money at 0, a production level of 0, all the way up to a production level of 2.5. And I think this is 2,500. I think they're in thousands. And then of course I have the curved bracket there again because we don't lose money at 2.5. We don't make money. We don't lose money. That's our break-even point. And then we lose money again once we get to 26 2/3, 26.67, and we would continue to lose money if we kept making this product ad nauseum until our machinery broke. So those are the intervals of profit and loss. Now the vertex gives the maximum, the optimum quantity, the quantity that we would manufacture to get the most profit and the maximum profit. So all we have to do is just find the vertex, and that will give us this quantity and this profit. Well, to do that, we take the original profit function. In this case, factoring out -10 would have an adverse effect. Or it could, and so we assign this number, the leading coefficient, as A, so then A is negative 60. And this coefficient, the coefficient of the linear term, to be B, 1,750, and place into this formula here. Negative B over 2 times A. Well, B is 1,750, we put that there. A is negative 60, so we put that there inside parentheses. 2 times negative 60 is negative 120. And the two negatives cancel out and make this a positive. And 1,750 divided by 120 is 14.58 units. And we're not actually going to be able to manufacture 0.58 units. But go ahead and leave your answer as a decimal. That's okay. Then you plug that back in here for x to find the y value, the function value of the vertex, and that's $8,760.42, which is also, that's in thousands, so this could be 8 million, I guess, 768,420. But that's the way you determine that quantity and that profit, by finding the vertex.